Hello, welcome to National Engineers Week. At Boston Children's Museum, we love celebrating E-Week. One of our favorite things is working with real engineers and engineering students. This year, of course, we have to celebrate online, but that's okay. Today, we are going to meet Roz, who is going to tell us all about what it's really like to be an engineer. Enjoy.
Hi, Neil. My name is Rosalind Imbaro. I go by Roz, and I am a structural engineer with Simpson, Gumpertz, and Hager in Waltham.
Very cool. Hi, Roz. My name's Neil. I work at the museum, and I want to know more about what you do as an engineer. So you said you're a structural engineer. I've also heard the term civil engineer. Can you tell us a bit more about why I might be using two separate words and what the difference might be?
Yeah, so civil engineer is one of the oldest kinds of engineering in the whole world. And it's the kind of engineer that helps build roads, helps build houses, helps build buildings and bridges and pyramids, right? Were designed by civil engineers. And sewer systems and water systems. So obviously that's a very, very broad number of things which civil engineers work on. So I'm a subset of that where I mostly work on structures like bridges and tunnels and the MBTA system here in Boston. So those are the kinds of structures, that pieces of the infrastructure that I work on.
Very cool. And when you say infrastructure, can you tell us a bit more about what that might mean or include?
Yeah, infrastructure is a big word, but it's all of the things that connect us, right? It's the roads and the bridges, and the water systems and the electrical systems that power our houses are part of infrastructure. The internet now is infrastructure. It's all the things that connect us. And the civil engineers tend to work on the big ones that don't have electrons.
Sure, that makes sense. Uh, so I wanted to first rewind a bit. We were all children once, and I just was curious to know a bit more about when you were in school. When did you feel like you were started to get interested in engineering, and like what subjects did you like in school? Of course, all subjects are important, but maybe certain subjects became your favorite.
Yeah, I think I started pretty early. To be an engineer, you have to like math and science, and I realized pretty early that I was good at those subjects. Um, and so those are really important because we do a lot of math in our work, at least in civil engineering, we do a lot of math. And I played with Legos. I still play with Legos with my son. I played with other building sets, erector sets, and Lincoln logs, and all different kinds of building sets. So I always loved building. And then I did a school project in fifth grade to study architecture, because of course I didn't know the word engineer at that time, but I knew what an architect was, or I thought I did, um, because of the Brady Bunch. Their dad was an architect, right?
Sure.
And so I did this school project, and I realized that many times, but not always, the architects, they design the buildings and they make them pretty and they design how they look, but they're not always the ones that make them stand up, right? The engineer comes in and helps the building, designs the part of the buildings that stand up, right? The columns and the beams and the walls and things like that. So after I did that project, I realized I wanted to be more of an engineer, an architect. And then in eighth grade, we went on a shadowing day, right? And so I looked up civil engineers in my hometown, and there was only one. And I followed him around for the day, and we played with concrete and soil and dirt and all this cool stuff. And he said at the end of the day, he said, when you turn 18, if you need a job, come on back. I'll give you a summer job. And so I went back when I was 18, and he kind of remembered me, but he gave me a job. And so then I started working with concrete and steel and soil and dirt and those great things. And that kind of started my career.
That's really nice that you were able to talk about like your fifth grade and eighth grade touch points, because that means a lot for a lot of folks who might be watching who are maybe
Mm-hmm.
thinking the same thing. And I also wanted to kind of dig deeper into one thing you were talking about, which was uh, talking about how engineers would work alongside architects, perhaps, to make sure that what's being created is being done as safely and within the guidelines of mathematics and science. And so I wonder if you could talk a bit more about the ways in which, as an engineer, you have to work with others, because I know that's usually a very important part of any job, but definitely for engineers, right?
Yeah. So yeah, we will. First of all, we work in big teams. I'm usually working on my projects. We're working in teams of 5 or 10 people, because not everybody can know every piece of the puzzle. So if somebody's designing a building, the architect, sort of designs how the building looks and how it looks pretty. The architect also figures out important things like how many floors does it need? How many people are we fitting into the building? Right? How do we get people out of the building during emergency? Okay. And then my job would be to design the columns and the walls to make the building stand up. Now, I don't work on buildings so much, I work on bridges. So there's a civil engineer who's like a roadway engineer, and they figure out, okay, how many lanes does this highway need? Is this 2 lanes? Is it 4 lanes? Does it have to go over a river? Does it have to go under a river? And they lay out the roadway, and then I design the bridges that in that roadway. And then another engineer actually designs the road, and another engineer designs the traffic lights, right? So there's a very, very big team, and everybody has their little piece. And of course, not only do we work with others on our same team, but we have to work with others in our company. And, I have to work well with my bosses and then the people that work for me on my project, right?
Yeah, that all makes sense. And I'm sure you also have to like at least communicate with the people who might then be in that structure that you're creating, right? So it's not just internally with your team, but then also perhaps if it's a building where people will be working, you'll need to be talking to the people who are actually going to work there, right?
Right. Yeah, there are different kind of engineers need to know, okay, what places need to be near other places. Does the mailroom need to be near this? Does this office need to be there near that office? Um, if there's a laboratory, where's the laboratory going to go with respect to the offices? So there's a lot of planning that goes into these projects.
Yeah, sounds like there's a lot of detail that goes in. And you mentioned Legos before. So, of course, I built many Lego sets myself. And one thing I noticed when I build a Lego set is I can sometimes get frustrated. And I'm wondering if, like, that's just one example of when someone could get frustrated. But I imagine working as an engineer around the clock, maybe you might also be facing frustrations sometimes. And how do you handle that?
So that's a great question. Um, yeah, we all get frustrated, and that's okay, right? Sometimes you get frustrated because you're tired and you've worked a long day, and sometimes you get frustrated because a coworker doesn't do what you thought they were going to do. And sometimes you get frustrated because the problem is hard, right? So, um, one of the things that we do in engineering is we do a lot of, or some engineering, we do a lot of experiments, and you try things, and if they don't work, you try them again. Now, my experiments are mostly on paper. I'll try something on paper. I will analyze it, sometimes in a computer model, sometimes with a pencil, and see if I think it's going to work. And if it doesn't work, I change it. So it can be frustrating if you don't get the answer at first. But of course, the way it works is you don't get the answer until the last time, and then you can stop, right?
Sure.
And one of the tricks of being frustrated and how I handle it, like everything in this world, is just try to be empathetic with the people around you and know that they're struggling with their piece of the puzzle, and everybody's trying to work towards the same goal. Um, and we do fun things. We take breaks, we take lunch, we go to lunch together. We hang out together after work sometimes. So we do other things to build friendships with our coworkers that are not just about work. So we have that personal connection, which helps too.
Yeah, I'm glad you brought up friendships at work. Of course, everyone will find times when they might be frustrated in the work they're doing, but that doesn't mean there aren't also good things or nice things that come with the same job. So, including friendships, but like, what other things are you able to highlight as what you consider to be like your favorite part of your job or the things you really like about your job?
Um, Favorite part of my job, and I have some things I can show you, but the favorite part of my job is my job in particular. It's big, right? The structures I work on are big, and I can take my mother to go see them, and I can take my brother to go see them. Um, and they are structures that you may have driven over or driven under. Um, and so when I create something as an engineer, when you build something out of Legos, maybe your mom lets you keep it up for a week and then you got to take it down and put it away, right? She doesn't want it on the dining room table.
Right.
But when I build something, it's going to last for years and years and years. Um, and I get to see it. So I think that's probably the favorite part of my job. I also really like working with other people in a team. That's the way I like to work. So it's the kind of job where you have to work in a big team. And I've been very lucky that some of the things that I've worked on are right here in Boston.
Hmm.
And so sort of feeling like I'm connecting to the community and I'm doing something that kind of connects to the community is pretty interesting.
What are some of the things around Boston that you have worked on, if you're okay with sharing?
Yeah, and I can share my screen if that's okay.
Yeah, please do.
Here's here's one of my favorite examples. I love this. So every year, college students come to Boston, and there's this little tunnel, which is the Starro Drive Tunnel, and it's located by the Hat Shell, by the Esplanade, right? And every year, the U-Haul trucks come with the college students, and inevitably, one of them hits this beam every single year, and it opens it up like a can of sardines. Right? Not that we eat sardines much. So this steel beam, this beam is made of metal, has been hit dozens and dozens of times. So I designed this concrete beam up here to take its place. So that concrete beam now does the work of the steel beam, and the steel beam can just be left as a bumper.
Cool.
And this picture was taken only 2 weeks after that concrete beam was finished, before the first college kid hit it.
Wow.
Yeah. Another one that might be fun is, if I can get this one up. This is the kind of machine that we use to inspect bridges. And I've been in those buckets, and it's really cool. It's kind of like a telephone truck, right? That goes up to the telephone pole, which a lot of us have seen, but this one goes underneath so that you can go under the bridge and inspect all the beams underneath the bridge. And sometimes we demolish bridges, right? I'll put it here. So I actually helped. This bridge had served its useful life. This was down in Jamaica Plain, called the KC Overpass. And they didn't need it anymore. It was old, it needed to come down, and it was kind of separating the neighborhood, right? It was kind of breaking the neighborhood in half. So I actually engineered how to take this down, and I had to do mathematics to figure out if we could get those excavators up on the bridge to demolish the bridge.
So like, will it fit? How heavy is it? Things
How
like that.
heavy are they?
Right.
Right. Will the concrete take it? Will the steel take it? Here's another one I loved. This was a bridge also being demolished. That they were. This is a railroad bridge down in Hyde Park, and they had to take out the old bridge because you can't stop the trains, right? It's very, we don't stop these trains for anything, right? So we had to take out the old bridge on Friday night, and they put a whole new bridge in on Saturday night because they built the bridge in the parking lot and they basically swapped them. So I did the mathematics on these cables and on the connections and on the crane, and I'll show you the crane. Thumbs up. This was one of the biggest cranes. It's one of the top 5 biggest cranes in the world.
Wow.
And it was coming from Europe, and it came to the site on 92 trucks. They had to put it together. It took 2 weeks to put the crane together to be strong enough to lift the bridge.
Yeah, I mean that bridge must weigh 100 tons, or is that? I mean, like thousands and thousands of pounds.
That is an excellent guess. It was 200 tons.
Wow.
Very, very good guess. Yeah, it was 200 tons.
Heavy.
Yeah, it was, and of course, it has to be strong enough to support trains, which themselves are very heavy.
Yeah.
So I'll just go through some of these examples.
Yeah, please.
That I happen to have. So this is bridges that I've worked with on schools. So sometimes I help schools do their bridge competitions. Some of you may have done that, right? This year they were doing their bridge competitions out of playing cards and Scotch tape.
Cool.
So this is what some of the bridge looks like. The student bridge looks like, and this is what the truck, right? That's the truck that they would hang the weights from for the bridge. I enjoy working with the students.
Yeah, I love those projects.
Yeah. And then this is the downtown crossing, which is the subway, right? And I don't always work on bridges. I also work on other things. So this is one of the examples where we were trying to fit a new elevator, right? Because Boston's subway system is very, very old.
Right.
We don't always have elevators in all the stations, and we need more elevators to get more access for people who need it. So this was a study that I did to try to see if we could fit. You can see there's the red line tunnel, and over here's the orange line tunnel, and this would have been a new elevator, and then some new stairs going around the elevator. This was one of those experiments that I talked about where we tried to see if this was going to work. This one didn't work, and that's okay.
Okay.
It didn't work out the way we worked, but we worked really hard to see if we could figure out where to sneak an elevator. This is one of my favorite ones. Now, this is not one of the ones that I personally did because it was done many hundreds of years ago. Not many hundreds, about 100 years ago. And at Government Center Station, the green line is on top and the blue line is underneath. Okay. Some of us have been there, right? Government Center Plaza. What was interesting is that the green line was built first. And they actually had to dig the blue line underneath the green line. Okay. So this is kind of what it would look like. Here's the green line on top, and this would be the new blue line underneath. Well, how do you dig a new tunnel underneath an old tunnel without that one collapsing, right? So this is the green line tunnel, Now, this was done 100 years ago, so I don't really know how they did it, but I have a theory. I have a theory that they got some UFOs that held up the green line beams with laser beams, tractor beams, right? And then they excavated out all the soil underneath. And this part is true. They hung the new columns from the bottom of the old footings. And then they cast new footings around the bottom. And then that was it. So that was a pretty interesting way. They actually had to do that to figure out a way to put the new columns underneath the old columns. That was a very, very difficult problem, especially for about 1915.
Sure. Yeah. Wow.
So those are some of the examples of things I've worked on. So I've worked on things like Starro Drive around here. I worked on the big Salt and Pepper Bridge, which is the Longfellow Bridge over the Charles River.
Yeah.
We helped retrofit that, right? Because it already existed. So we wanted to strengthen it for an earthquake. So if an earthquake came, it would last another 100 years. This is one of the towers. I think you can see. Can you see that tower? Okay. So we talk about Lego. So this is the Salt and Pepper Bridge, right? And it's a very historical and important bridge for Boston.
Right.
So we actually, not myself, but my company helped engineer, and then the workers took down every one of these stones, labeled them. You can see you can see the stones here. They labeled them, they cleaned them, they photographed them, they numbered them, and then they put them all back up in the same order.
Wow.
And you can see how beautiful and shiny they are now, how white and pretty they are. This was after they were being rebuilt, and it's not quite finished. You can see at the top that the tower is not quite finished yet. But that's one of those examples of something that kind of is built like Legos. And I can show you, and I can show you this too. This is kind of fun. This is this will open up. This is a view I took from the top of one tower looking at the other tower.
Right.
So sometimes it's good not to be so afraid of heights. If you're my kind of engineer, we have to climb things.
Sure.
Other engineers stay more on the ground, but structural engineers and civil engineers sometimes have to go up on the buildings and see what there is to see.
Some might say the heads are in the clouds sometimes.
Sometimes, yes.
And I actually really love this example because, to take a step back, everything is being changed and made to be modern, and there are all these new techniques, but it's important for us to remember that there's sometimes history and art that we don't want to replace. So, this is an important example of how, and that's why, we at the museum, we celebrate STEAM as opposed to like STEM. And that's because you really can't design something without factoring in the aesthetics, the art, the way it looks. There's a certain amount of creative expression, and there's a certain amount of story and narrative built into even these towers here, which is why you took the steps of labeling them, right? So I really love that example. Thanks for sharing.
Yeah, so that's something that everybody knows, right? Yeah. So that's why it's one of the reasons I like my job, because that's something that everybody's familiar with, that, or many people are familiar with that bridge.
Right. So one thing I want to make sure I touch upon. So when celebrating Engineers Week at the museum, we have this like unofficial slogan we use, which is that engineers use stuff to make stuff that does stuff. Can you tell us how maybe like that applies to the work that you do?
Yeah, and in the real world, it's probably many more stuff than that, right? It's many more steps than that.
Sure.
But maybe a simple way is that I use computers and math and physics to design and construct bridges and tunnels that carry vehicles, trucks, and trains.
Awesome.
Right? And so and everybody talks about bridges, right? You talk about bridges connecting people and things like that. So it's used in metaphors a lot, about getting over obstacles, crossing that bridge when we come to it.
Sure.
So it's very poetic to actually work on bridges.
Oh, that's such a nice thought. Yeah, that's a really good way to think about it. Another question I want to make sure I asked was, switching gears a bit, what sort of like challenges did you face, sort of like in your journey to get to where you are now, in your job you are now?
That's not a big challenge, but it is something. We have to take exams, right? So getting a college degree is not enough. Engineers that do what I do have to go take a 16-hour exam to get licensed. Like a doctor has a license, or a lawyer has a license to practice law. I have to have a license to do what I do, and that exam it's 2 days to do that exam.
Well, that makes sense because the work you're doing has an impact on the safety of people, and if you're building bridges, you want to make sure that there's a license for the person making it, right? So I understand.
Yeah, we have a saying actually in civil engineering that if a doctor makes a mistake, one person gets hurt, and if we make a mistake, a lot of people can get hurt.
Right, that's fair.
Yeah, so those are the biggest challenges.
That all seems to fit. And I've been asking you a lot of questions about what it's like to be an engineer, so I thought I would take a step to the side and actually ask you a bit more about yourself outside of your work. What do you do for fun? How do you spend your time when you're not, at work as an engineer?
So I'm from Boston originally. I'm from here, and I went to school here. I went to school at Tufts. Lived here my whole life, and I now have an 8-year-old son. So outside of work, we play a lot of games. We do a lot of bike riding. We do some hiking. We love to be outdoors hiking, either Blue Hill or Wachusett or any of the local places, Mount Monadnock.
Love Monadnock.
Yeah, I still do a lot of reading. I loved all the great science fiction stories and the Harry Potter books and all the very popular things. I read all of those, and I still like to read those. But it's mostly just playing, and I still play Legos with my son, and we do puzzles and and like everybody, sometimes you just sit on the couch and with a bag of potato chips and watch TV, and that's okay too.
That was very well said, and I really appreciate the glimpse into all the work you've been doing in the area. And I don't want to keep you too long. I know it's still daylight out, so I appreciate your time, and we'll connect with you again at some point to check in and see how you're doing.
All right, thanks for having me.
Thanks. Take care.
Take care.